Hi, welcome back to Musin Chemistry. This is the electron configuration lesson of aluminum. All right, aluminum is 13 on the periodic table, so we're going to write a 13 there. And its atomic mass unit is 26.98, but we're going to call it 27. I'm just going to round that off. Okay? So we have 13 protons because the atomic number is 13. And since aluminum is electrically neutral, we have to have 13 electrons. Now, what about the neutrons? Well, again, we just do AMU minus protons equals neutrons. See that? So you go 27 minus 13 gives me 14 neutrons. All right, it's pretty darn snarly there. So put a 14 there. Now, before we do the electron configuration, let's look at a couple things. S can hold 2 electrons. The P shell can hold 6 electrons, the D shell can hold 10 electrons, and the F shell can, of course, hold 14 electrons. We're going to use something called the diagonal rule, often known as the off-ball principle, and we start at the top of this slide of this red arrow, and then we're going to just follow down until we actually run out of electrons. It's pretty simple, right? Okay, let's go do it then. So, the electron configuration. This will be 1s2, we just went through that one. 2s2. See how easy this is? 2p6, 3s2. And now, let's 4 and 4 is 6, make 10, plus 2 make 12, so we need 3p1, right? Pretty darn snarly, I'd say. 3p1. All right, well, let's go ahead and do the orbital notation next. All right, so remember that S has only one subshell, right? So you have one S, and Hund's rule says you have to put an up arrow in every subshell before you do a down arrow. Well, 1s only has one subshell, so there you go. 2s, okay, up arrow, down arrow. Then we have 2px, 2py, and 2pz. So we go 1, 2, 3. Following Hund's rule, 4, 5, and 6. Pretty easy, huh? Then we have 3s, up and down. Then 3px, 3py, and 3pz. And yes, we do need to have all those subshells, because remember that electrons can become excited. They can jump suborbits or even orbits themselves. So let's do this here. And up there. Okay, noble gas notation. All right, this is pretty snarly, guys. So we look at the noble gas. The nearest noble gas to aluminum is neon. Remember, you can't do the one after aluminum. Has to be the one for aluminum. So we get neon here. All right, and now we look at our valence shell. Let's find our valence shell. Here it is. It's the last shell. Right. So we would write 3s2, 3p1. Pretty darn snarly, I have to say. So the quantum numbers. Yee doggy, yeah. So we have N, L, M, and S. Well, what period is aluminum in? So we look at the principal quantum number, which is our N number, and that tells me, hey, I'm in the third period. So we write down. All right, we're in the P block, so our angular momentum, our L value, is going to be 1. And since it's the first element in the P block in that period, it's going to be minus 1 there, right? So we're going to put a minus 1. And let's look at our last arrow right here. It's going up. So our S value is going to be 1/2 positive. Well, that's it, guys. You be snarly, and we'll see you back here at Musin Chemistry.